In this video, I'm going to talk about one of the ways you can diagnose whether you have an AR1 process or an MA1 process, or in fact, if you have something else. So we're deciding between whether we have this type of process, an AR1, or whether we have an MA1 process. So the first step in this sort of diagnosis is to plot the series. So if we take a plot of our series xt across time, then for it to be either of these processes, we have to have that it has a constant mean, which is 0. So for both of these processes, we have to have a process which looks something like this, where this value here is 0. If it doesn't, then it can neither be an AR1 process, nor can it be an MA1 process. Similarly, we have to require that our process has a constant variance. So that just means that our variance of our process looks relatively constant across time, because if it doesn't, then similarly it cannot be an AR1 nor can it be an MA1 process. Okay, so that's how we diagnose if it is an AR1 process or an MA1 process. How do we decide between them? Well, in order to do this, we need to look back to what we derived before for the covariance of an MA1 process. So looking at an MA1 process, we derived that the covariance between xt with xt plus h was equal to, if we had h equal to 1, we knew that this was equal to theta times sigma squared. If h was greater than 1, we found that the covariance was equal to 0. So we had this type of covariance structure. Furthermore, we derived the variance of our process. The variance of xt was just equal to sigma squared times 1 plus theta squared. That was just what we derived before. So combining these two things, that allows us to come up with the correlation of xt with xt plus h. For the example of an MA1 process, this would just be equal to theta times sigma squared divided by sigma squared 1 plus theta squared. That's for this circumstance where h equals 1, and it's equal to 0 for h is greater than 1. And actually we can simplify this correlation a little bit, because we recognise that sigma squared is both on the top and the bottom. So the correlation is just theta divided by 1 plus theta squared. And just to remind ourselves, this is just for an MA1 process. Whereas for an AR1 process, we derived the correlation structure here, and the correlation between xt and xt plus h was defined as being, well, we found it was equal to rho to the power h, where rho is the constant which we find in our AR1 process above here. So notice that these two correlations are actually different from one another. And that's actually going to form a basis of a way of testing whether our process is an MA1 process or whether it is an AR1 process. Because note that we can't tell by looking at the mean nor by looking at the variance whether our process is MA1 or whether it's AR1, because both of them have a mean of 0 and a constant variance. Whereas the difference comes in the fact that there is a different correlation structure. And we can use that difference between the correlation structure to help us diagnose which type of process we have. And that's what I'm going to do in the next video.